Hello, and welcome to Beginning C++ Programming. Thank you very much for enrolling in this course and placing your confidence in the Learn Programming Academy team and in me for your training. In this video, I'd like to introduce you to the course, but first I'd like to introduce myself. My name is Frank Metropolis, and I'll be your instructor for this course. You can read more about me in the course bio, but I want you to be sure that I will do everything I can to make sure the course content is correct, relevant, understandable, and hopefully fun. I've been a university computer science professor for many years. I've also worked in industry as a programmer, software engineer, and project manager. I've taught thousands of students in both academia and industry how to program using many programming languages. But C++ is my favorite language to teach. I first learned C++ back in 1988, and I've used it ever since. That's quite a long time ago, and C++ has evolved greatly since then. I'm very excited to teach this course. I hope you're also excited about learning C++. In this course, I assume that you're completely new to C++. I also assume that you have little, if any, programming experience with other programming languages. If you do have programming experience, that's great. This course is still for you, since you'll definitely learn C++. The course curriculum has been developed in a way that introduces new topics in a specific order. I encourage you to follow along one section at a time. Before you know it, you'll be writing C++ programs that solve problems. In this course, I'll cover modern C++. I'll talk more about just exactly what modern C++ is as we go through the course, but rest assured that you'll be learning C++ as it should be used today. Over the years, I've worked with many students, and I can only remember a few that just didn't get programming. I still think that if they tried a little harder, then programming would have clicked at some point. If you're new to programming, you will at some point in this course feel frustrated. This is perfectly normal. Programming is a skill that must be learned and practiced. You play a musical instrument? Do you remember what it sounded like the first time you played? Do you remember wanting to smash that guitar or piano because you just couldn't get it? Programming is similar. You must practice and practice to get better. If you get frustrated, take a break and try again a bit later. Remember, we've all been there. I still remember the first program I ever wrote. It was back in 1980 using a programming language called Fortran 77. I was so excited that I was able to program a computer to do exactly what I wanted it to do. The program was pretty simple. It asked the user for an amount in US dollars and then displayed how many quarters, dimes, nickels, and pennies it would take to add up to that entered amount. We'll do the same problem in this course. I also remember that it took me maybe more than a couple of attempts before it was correct. But man, what a great feeling when it ran correctly. In this course, each section ends with a challenge exercise. These will help reinforce the concepts presented in this section to help in learning the material. Once you finish the challenge, don't stop there. Challenge yourself. Come up with similar problems on your own and solve them. Then do it again and again. Make it fun. Make the problem silly if you want to. It doesn't matter. It's all about practice. Finally, if you have any questions at all, please ask them in the forums. I will personally monitor the forums and respond to questions. Before you post, though, browse the already answered questions, since your question may already have an answer. Well, enough talk. I look forward to working with everyone. Let's start learning C++. One question that students often ask when they're considering a career in software development is, what programming language should I learn? There's really no easy answer to that question. Experienced professional programmers generally know many programming languages and use them based on many factors. The question I'd like to address in this video is, why learn C++? Let's start with C++'s popularity. Much, if not most, of the software written today is still written in C++. And this has been the case for many years. There are many programming language popularity indexes that use different criteria for ranking the popularity of programming languages. Let's head over to a browser and we'll look at a few of them. I've opened up a browser and I've loaded several sites that rank programming languages based on popularity. All of the data I'm showing is current as of November 2017, so depending on when you access the site, your results may differ. Each site uses their own criteria, and I encourage you to browse through these sites. I've provided the URLs for these sites in the course resources. First, let's look at the TOB index. As you can see, C++ is currently ranked 3rd. If you select that row, You can learn more about C++'s popularity since 2001. It's pretty impressive for a language to be ranked so consistently for so long, considering how many new languages and frameworks appear on the scene. The next site is the PYPL Popularity Index. As you can see, C++ is currently ranked 6th. Next, we'll look at the IEEE Spectrum rankings. On IEEE Spectrum, C++ is ranked number 4. The RedMonk ranking has C++ at number 6. And finally, we'll take a look at ZDNet's rankings. They combine popular indexes and create an ensemble ranking which shows C++ at number 4. They also provide an analysis of the data that's a good read. Let's return to the slides. As you can see from these sites, C++ is still a very popular language among software developers, and the ranking is consistently high. If you go to GitHub, you'll see that there's a huge number of active C++ repositories, and C++ is also extremely active on Stack Overflow. Popularity is important, but C++ is also a relevant language. There are many leading software titles written entirely or partly in C++. These include the Windows, Linux, and Mac OS X operating systems, many of the Adobe products such as Photoshop and Illustrator, the MySQL and MongoDB database engines, and many more. Leading tech companies use C++ for many of their products and internal research and development. These include Amazon, Apple, Microsoft, PayPal, Google, Facebook, Oracle, and more. Finally, the types of projects that C++ is being used on are pretty cool. In many cases, these are the engines that drive many popular frameworks. For example, engines for virtual reality, the Unreal Game Engine, machine learning, network and telecom, and more. There are many reasons why C++ is so popular and relevant, but the main reason is because it's so powerful. What do I mean by powerful? C++ is super fast. It's a general-purpose programming language that supports both procedural and object-oriented programming, making it very flexible. It scales easily, and it can also be portable. C++ can do many things that other languages just can't. That's why nearly every major language has a way to interface with the code written in C++. With all this power and flexibility comes complexity. There's no question that C++ is one of the most complex programming languages out there, but learning the basics is pretty easy, and that's what this course is all about. Finally, you've probably heard that C++ programmers command higher salaries. This is true. You may have even heard the phrase C++ equals salary plus. Career opportunities are out there for C++ programmers. I've consulted for many years with major U.S. corporations on the hiring of software developers. This includes full-stack developers, Java developers, iOS and Android developers, and C++ developers. Having C++ skills on your resume is often like a badge of honor among software developers, and many times it'll get you that job interview. Why? Because C++ programmers have a skill set that sets them apart from many other programmers. One final thought. Since so many programming languages are influenced by C++, learning new languages is often easier since you already have solid foundation in a root programming language like C++. As you can see, you've made a good choice in learning C++. In the next video, we'll briefly look at the evolution of C++ and the C++ standard. In this video, we'll take a brief look at the history of C++ based on some major language milestones. In the early 1970s, Dennis Ritchie created the C programming language at Bell Labs. The development of C was closely tied to the development of the Unix operating system. In 1979, Bjarne Stroustrup started working on what became C++. He initially called it C with classes. His idea was to add to C object-oriented features that he knew from a language called Simula. In 1983, the name was changed to C++, and the first commercial release was in 1989. In 1998, the C++ Standards Committee published the first C++ standard, informally known as C++ 98. Multiple issues with C++ 98 were addressed, and the C++ 03 standard was released. Then in mid-2011, the C++ 11 standard was released, and then after that, C++ 14 and C++ 17. As you can see, C++ has been around for quite some time. Notice that I've bolded and italicized the last three standards. These standards are sort of a renaissance for C++ that changed the language going forward. These changes are what modern C++ is all about. Generally, C++ that's based on the language as defined before the C++11 standard is considered classical C++, and C++ based on C++11 and forward is considered modern C++. That's fine, but what does that mean? Well, modern C++ is a way of saying that it's C++ as defined today, with new ways of managing objects in memory, lambdas, smart shared pointers, threading, and more. These terms may not mean anything to you yet, but modern C++ feels like a new programming language when compared to classical C++. In fact, Bjarne Stroustrup described modern C++ as a new language, one with modern abstractions for ease of use and power. Along with the language features themselves, modern C++ is also about best practices and core guidelines. In this course, we'll be using modern C++. As we go through the course, I'll sometimes mention that this feature was introduced in C++11 or C++14 and so forth. I'll do that for a few reasons, but the most important is so that you know where to look for this feature as your C++ studies continue after you finish this course. I'll also show you best practices and gotchas that you should be aware of. If you're new to programming, you may be wondering how all this works. After all, it sometimes seems like magic. How can we get a computer to do what we want it to do using a programming language? Let's see in the next video. In this video, we'll take a high-level look at how all this works. If you're completely new to programming, then many of these terms will probably be new to you. The most important thing to remember is that the computer isn't smart at all. It simply does exactly what it's told to do by the programmer. And the programmer in this case is you. A computer program is like a recipe. If you want to bake a cake, there are a series of tasks that you must execute in a specific order, otherwise the final product won't be a cake. Suppose that one of the tasks is to put 4 eggs in a bowl and mix. A human might assume that the number of eggs need to be cracked and only the egg whites should be used. But that's not necessarily true. They might assume something else. See, that's the problem. A computer would probably put the eggs, shells and all, into a bowl and mix them. So when we write programs, we need to be very, very explicit about what we want the computer to do. Otherwise, our result will probably be incorrect. In order to write programs, we use programming languages. There are many, many programming languages out there. In this class, we'll be using C++. The code we write is called source code. Source code is generally higher level than computer code since it needs to be understandable by humans, and humans aren't very good at reading long streams of zeros and ones. We write our programs using programming editors. These editors are like word processors specifically designed to write these recipes in a specific programming language. C++ programs have an extension like .cpp, .h, .cc, .hpp, and there are several others. In this course, we will use .cpp and .h as the extensions for the code we write. Just as humans aren't very good at reading computer code, computers aren't very good at reading source code. We need to translate the source code to a form that's understandable by the computer. This form is called object code, and the compiler is the translator. The C++ compiler is a program that takes as input C++ source code and produces object code as output. If the source code has errors, then no object code is produced. Since our code might depend on code that other programmers wrote, this is actually a very likely scenario because we want to reuse as much existing code that's out there as possible. This makes it easier for us to solve our problems. So, a program called a linker takes our object code and the object code that exists out there in the form of libraries and links it all together to form an executable program. That is a program that we can now run that follows the recipe we told the computer to do using C++. Now that our program is complete, we test it to find as many errors as possible and we debug it to eliminate those errors. As you can see, there's a lot going on, and understanding what's going on at this high level is important. The integrated development environments are programs that allow you to do everything I just mentioned from a common interface. Sometimes they make the process seem like magic, since all you need to do is click a button and the entire build process happens. Let's go over this build process one more time in a visual manner. First, we use an editor to enter our C++ code or to edit existing C++ code. Note that we can have many C++ source files. In this course, we'll be using a single main.cpp file until our programs get larger. Then we'll need several C++ source files to better organize our program. Production C++ programs can have hundreds and even thousands of source files and millions of lines of code. Then we need to compile the C++ code using a C++ compiler. If the code contains no syntax errors, then the compiler will generate an object code file for each C++ source file. On Windows, the object files have .obj extensions, and on Unix and Mac, they will have .o extensions. Finally, the object files and any libraries that our program requires must be linked together. This final step creates an executable file that can run. On Windows, the file extension will be .exe, and on Unix and Mac, they typically don't have any extensions. But remember, we're not done yet. You must test your program to find any logic errors and debug it to eliminate those errors. Let's wrap up this video by looking at some of the available IDEs that can help us with this process. As mentioned previously, IDEs are programs that provide an editor, a way to compile, link, and execute your source code. They also often have debuggers that can help you understand your code and fix errors. Most beginning C++ courses don't cover integrated debuggers at all. I think this is a mistake, and I plan to cover the debugger once we have the basics of C++ behind us. IDEs also help us keep our files in sync and provide hooks to version control systems such as Git and Subversion. There are many IDEs available. I've used all the ones listed here and others. The selection of an IDE for this course was not an easy one. I wanted an IDE that was free, cross-platform, and had a relatively small hardware requirement to run. In this course, we'll use CodeLight as the IDE since it meets all of these criteria. However, there is no perfect IDE. As a professional developer, many times you use whatever IDE is used by the team you're working with. As a consultant, you should learn as many IDEs as you can and always have an editor command line preference available as well. As you gain experience in C++, I encourage you to experiment with the various IDEs and find one that works for you. Let me talk briefly about the ones that are listed here. CodeLight, as I mentioned, is the IDE that we're going to use in this course. It's free, it's cross-platform, it's fast, and the memory requirements are minimal. CodeBlocks is also a nice cross-platform IDE. However, the Mac version is pretty buggy, and it kept crashing on me all the time. NetBeans is the Oracle IDE. It's used mainly to develop Java code, but they've got a plugin for C++ that's actually very good. It's a great cross-platform IDE. The problem is that it requires a Java JRE install, and the memory requirements can be pretty significant. Same thing with Eclipse. It supports many different languages. It's cross-platform, but it's got pretty good memory requirements. CLion is an IDE by JetBrains. This is the company that's created Kotlin, IntelliJ, Android Studio. This is an awesome IDE. This is my IDE of choice, but it's not free. It's actually quite expensive. But there's a download available that gives you a 30-day trial, and you can try it out and see if you like it. DevC++ is a C++ Windows-only environment. It's small, it's fast, and it's a nice IDE, but again, it's Windows only. KDevelop is a cross-platform, multiple language IDE. However, there is no Mac binary available. If you want to use it on Mac, you have to build it from the source. Finally, Visual Studio and Xcode are Microsoft and Apple's development environments, respectively. Visual Studio is a great development environment. It runs on Windows only in the C++ version. They have a Mac version of Visual Studio now, but it doesn't support C++. And Xcode is Mac only. It's a great development environment. If you're a Mac developer, you're probably already using it for iOS development, Mac OS X development, Swift development, and so forth. But as I mentioned, it's Mac only, but it's a great development environment. There are many more IDEs available. If you find one you like and you think others in the course should know about it, please post that information about the IDE in the course forum. Well, that wraps up this video. I hope you now have a better understanding of the build process in C++ and how IDEs can help make programmers more productive.